Welcome, everyone. Today we're going to be talking about math art. I'm Pamela Schultz, for those of you who maybe haven't attended a webinar before. I think this is going to be a fun topic. DataGraph is a program that you can use, obviously, for graphing, and a lot of people use it for creating professional graphs, but I sometimes just find myself playing with the program and just making kind of interesting things that I just to pass the time. Sometimes it's sort of a fun thing to do. So there's a few examples that we're going to go through today. And I guess I wanted to just start by showing you one of the examples that I thought was a really fun example that we did that I used to promote what we're talking about today. So let me start by sharing my screen. The Math Cat is an example that a friend of mine, her daughter, did this project, Bridget Buchanan. Thank you, Bridget, for letting us use this. And I thought it was so cool. She very meticulously came up with each one of these functions and the range over which they needed to be drawn in order to create what you see here. And again, if you go onto our YouTube channel, there is a demo that shows you step-by-step how to do this. When the project was done, let's see, I think I can show you this. This is the original project and each one of the functions. And again, we took this into DataGraph, and I have all sorts of versions of this that I have created over time. I think this is kind of a cool one, but this is just, again, an example of doing something just completely different with DataGraph and kind of a fun example. This is using a function command. So each one of these lines is just drawn with that function command, and again, providing the extent of each line. There's a demo of this that's online. You can go on YouTube. You can go through that demo. Part of the reason that I think this is a good topic to go through is because just to try and illustrate to everyone, when we're using DataGraph, we use it for so much more than just graphing. When I do any kind of icons or thumbnails, I always use DataGraph for things like that. So in some sense, this is, I guess, introducing you to the concept of using DataGraph for design, and trying to, again, use some fun examples for this. Let me show you briefly an overview of the examples that I want to show you today. So the first one is really kind of a cool example that I got inspired to do this from this book that hopefully you can see here. It's called Optical Magic. And there are some really, really cool optical illusions that are in this book that this is inspired from one of those, where if you look at this particular image, you get the sense that the bottom line is not as curved as the other lines, but in fact, these are all the same circle, just cut off at different points. So I'm going to show you how I created this in DataGraph. The other example that I'm going to do that you should be seeing now, this is a Spirograph, and this is, in some ways, I kind of randomly combined a bunch of different variables to come up with the image that you can see here. But this is using a function and calculating these values and using different sliders to kind of adjust them and overlaying different elements to come up with the image that you see here. So this is, again, all made within DataGraph. The other one that I want to show you is something that we posted actually online. And I think that, let's see, navigating my multiple windows here. Can you see this animating? I'm just sort of curious how well this is working. If someone can let me, okay, so great, you can see this on the chat, or someone let me know on the chat that you can see this animating. So there's a lot of different elements that are in this particular image, and this is all created with DataGraph. You have at the bottom these sine waves that are moving in, in different, at different speeds. The moon up in the corner. And notice how there are even stars that are pulsing at different rates. And then I added this swan into that. So this is definitely one of these things that I did just where I started adding elements and then thought more about what to add. And it's just kind of grown over time. And definitely just kind of for fun. But again, knowing how to control all these different elements and to piece them together, none of them are really necessarily that complicated. There's math involved in terms of figuring out how to do this, but they're all individual elements that are combined within the program. Were exported as an SVG with the animation effect export with it. I guess I don't know about using SVGs for an actual for a video like that, but this, what in DataGraph, what we do is you can export this as an MP4 file, and then you have the animation that goes with it. I think if you actually like what you see right now is just the static image. If I exported this as an SVG, it would just be the static SVG. Yeah, I think that is correct. So I don't know. I guess that's an interesting question, but definitely as an MP4, I'll show you how you can export it as an MP4. And start again with the first example here, which is the example with the overlapping circles. So if you can see this one, make this just a little bit bigger, and you look at these lines, also with the checkerboard, it sort of plays with your perception a little bit. I know it plays with mine. And this tends, again, the one that's at the bottom does not look as curved as the other two, but sure enough, if I remove how this is clipped, you can see that these three circles are exactly the same size. Okay, so how did I create this one, just as a simple one to start with? And I guess one of the things to recognize, just to start out, let me just make a brand new file completely. And I've had a couple of people recently asking this question about the box that you see when you first open the program and create a new graph. So the canvas basically has a section where we have our XY coordinate system. And then on the outside of that, we have what we refer to as the margins of the graph. And and as you know, that when you start out, the size is completely flexible in terms of what you see. So when I'm making a graphic like the ones that we've shown you, what I typically do is to set all of the margins initially equal to 0. So you don't have this space in between at all. So you can see here how the margins, if I open up the canvas, the margins will say automatic. But if I just set each one to 0, then that line you're no longer seeing because it's all the way out at the edge. Now actually, let me just I'll put a single point command in, which adds a single dot, and then you can also see the axis settings. So if I do the same thing, and actually let me just set this to a specific size as well, just so you can see this. So I've got this set to the default 5 inches by 3 inches. I'm going to change all my margins to 0 so that the whole thing is basically my XY coordinate system. And you can still see the X and Y range along the edge of the graph. So one thing that's convenient if you're doing any kind of a schematic, depending on what you're doing, and what, for some things this works, for some things it may not work as well, but a handy trick is to, if the size of the graph, for example, is going to be 200 pixels by 200 pixels. So say I'm making an icon for something, for example, some kind of a schematic, then I can set my, again, have my margin set to 0 and set the XY range also equal to a 0 to 200 range. So if I say, X is 0 to 200, and I can just paste that in here. So I'm doing this in my axis settings. This is 0 to 200. And if you want to really fix it to, again, be exact, then I can have it both in the include so that it has those numbers in the range, as well as just restricting to those values in the range. And now I have this box that I can draw things into, where if I, for example, want to place a, let's see, where's my marker now is down at 1, 1, but if I want it at 100 pixels and 100 pixels, I can type in 100 as my X and 100 as my Y. And now I have, I changed that. Here we go. Here. Now I have this point that is exactly at that location within my graph. And I can, change the size of this. Actually, I guess that's some of these sliders have a limit, but I could make this very big if I wanted it to. So now the actual size of my point is also 100 pixels. We can make this, here's the actual size. If I, again, put this into another document or something like that, then I have this point that you see here. And again, this just makes it sort of convenient. In some ways, you're then using DataGraph similar to you would like an Illustrator or another graphing program, where now you've created the canvas in such a way that anything that you place on this, any text label, for example, if I want this to be at a specific location, I could type in these coordinates and pixel offsets, and it would put it exactly where I wanted it to be. So in terms of the example that I was showing you, in fact, it's sort of funny that I did this with the point, because this is not how when I made the overlapping circles, I did not actually do this with just a single point command and making the circle really large. But in fact, this definitely is a way that we could do this. I guess one thing, when you're actually wanting to, if this was just the icon that you wanted to create, I don't know, we could add some more styling here. We can add, let's see, if I go into my canvas setting, then there's all these additional settings for other backgrounds that I could add. So I could add in some color. Well, we wouldn't necessarily want to use the same color, but there are also gradient options. So there's all sorts of ways to kind of, again, create this in a more schematic way and have that overlapping. So we'll go ahead and just add that. And then if we wanted to have, again, another circle that's of the same size, I'm actually just going to go with this approach since I think this works well. I can then just change my my Y value to be a slightly different value. Now I have my another overlapping circle. And if I wanted to have another one here, I could set another one. So then the question, or what we haven't been able to do yet, is I haven't shown you how do I clip these to create the look of the those lines. And the way that you can do this is by placing these all of these commands within a group. So I can highlight my commands, I can place them within a group. And actually, since I'm not using my data table at all, I might as well click this icon down here to swap my commands. I'll put this over on the left-hand side. So now I want to, again, I want to clip this with a region. And so notice when you create a group, there's this option of clip with down below. Now, initially there's nothing there because I haven't created another command that can be used for clipping. But if you've never used the range command, this is one of the commands that we can use. So I can click this, and then this will allow me to do all sorts of different things. But basically, let's actually put this at the bottom here. So when you create a range command, by default, it shows you a highlighted range over an interval. And right now the interval here is from 0 to 1, which again, if I show my X and Y coordinate system, the pixel system that I set up here, then you can see the 0 to 1 is going to be very small. So I'm not really seeing anything. So let's just make this very big. And now hopefully you can see that how there's an overlapping, partly transparent region that's overlapping my circles. And if I go back into my group that I created, and I go back to the clip with menu, and I'll say clip with, and this region is now there that I can select from. And sure enough, it will clip part of those circles. So right now it's clipping in the X direction. I want to actually clip in the Y direction. So I'll change this to being an interval. I can change the X to being everything, or let's see, is that what we had? I think that was it. 0 to 100. Oh, there we go. Okay. Okay, so we'll do that. So now you can see I'm actually clipping I'm showing basically the region that's shown for the circles is what's overlapping with this region. So since I want to clip I don't want to clip the top part, I want to clip or I want to show the top part. So we'll do opposite here and go from 100 to 200. There we go. So now you can see the lines have been clipped where I want them to be clipped. And if I now go into this region command, I can just make it completely transparent so it's not covering up my circles anymore. And then you get this look again of where the lines again give you kind of this strange look. And to allow you then to do the reveal, I can go into my definitions and create a slider that instead of just typing in the minimum value here that I'm going to clip with, let's see, because I think if this is, yeah, that's 0, then I'm not clipping anything. So if I create this slider to go from 0 to 100, so this will be my clip region, and I'll just set now this Y minimum equal to whatever the value is for the clipped region. So you can show someone this optical illusion and then do a reveal where sure enough, these are all the same circles that are overlapping each other. So there's a number of elements that are in this graphic. Again, utilizing the fact that we can set the pixel sizes to be the same as the extent of the XY region. In our final version, we wouldn't necessarily show we wouldn't need to output the X and Y. That's just for us in terms of being able to visually design things and place things on our graph, and then we have that ability to reveal. The other, I guess, cool thing that I did within the version that is here, so this is basically the same thing, but I actually used a different command. So I did this with using the command that's under here, the region command, and I created all these little ovals. Actually, in retrospect, doing this with the points command is easier than what I did here. But here I created this checkerboard pattern, which I think is pretty interesting. And this is again done with the range command, where if I just show you one of these, this is a range command that alternates in both the X and the Y direction. And this is pretty easy to set up because again, here I did this, here it's 400 by 400 pixels. I can set where I want the region, the highlighted region to start, where I want it to end. And I set this up to be 10 pixels wide in both directions. And if I have the second region command here, starting 10 pixels later, then I get this checkerboard pattern. So I don't know, I thought that was a pretty cool thing to do. Let me go ahead and zoom. Where are you? Okay, there we go. Okay. All right, so let's go ahead and move on. Hopefully that gives you just again a sense of how you could use this for making icons or other schematics. Let's move on to talking about the Spirograph. And this is really a fun example to work on too. So first, let me just show you, if we go back on this. There we go, all the way back to the beginning. So what is going on here? So I have a variable that I created that is n. So this is just the number of points that I have in this. And you can see how I'm calculating each of these spirals. And as I'm just adding more and more numbers, I'm going ahead and adding to the spiral. So basically what I have here is functions that I have set up in a column. So different than the MathCAD example, where in that example, you have a function command being used. Here, I'm calculating both the X and the Y value. So here's, I don't know if these two equations are exactly the same. So this is just a screenshot from online. If you want to check out the Wikipedia page, you can, let's see, if you want to Google Spirograph, I guess just for anyone who's also has never done this before. These are, I used to have one of these when I was a kid, where you have a pencil that you're tracing and you trace these various lines in different patterns, and you can create, kind of all sorts of interesting looking patterns from the Spirograph. So what we're doing is we're doing this here mathematically, and we have equations that we can use to come up with these various shapes. So the equations that I have set up here, let's go ahead and actually just look at what I have. There, I just put on the chat the equation for X, and then here's the equation for Y that I'm using in this file. And what you see in this is that there's a number of variables that are used in both equations. So I have my A, my B, my T, my H. And so what I did here is I have set up variables within the section where we have the global variables. I have a variable for A, a variable for B, I have H, and I have these other ones that I was sort of playing with here. But basically, if you want to take, again, we can do one sort of from scratch so you can see a little bit how this is set up, maybe without all this other stuff that I have here. So I can take my two function commands that I've already created, and I'm going to go into this new file, and I'm just going to paste this in here. So, so again, you can take what I've hopefully, I think you can copy and paste hopefully from the chat, get these equations. And when you first paste them in, you're going to see an error because I haven't defined what each of these variables means, but that's pretty easy to do. And I can do that down below in a couple of different ways. So I can set up sliders, for example, so I can have A, I can have B, I can have, let's see, I can have H, and now that I have I have those three variables set up, notice now I no longer have an error showing. And partly that's also because the variable T that's in these equations is set up as our global animation variable. So what's missing here right now is I'm not showing any number of rows. So there's no data currently used for this. So if I wanted to add one more variable, which would be my N for my number of rows. And now when you create a slider variable, if you expand that, you can set them to integers when you know something's going to be an integer and not a continuous variable. And I might want my N to go from 0 to 1,000 or something like that. So that this now, when I change N, it will change accordingly. And in each one of my expressions, I can set up my N value here. Now I have a lot of zeros set to my individual values, so nothing's actually being calculated yet, but at least you can see that all the variables have been defined. There's no error showing. And currently what it would be using for T is the global animation variable. So let me just go ahead and close these and start. What I often do when I'm creating something like this is just start changing some of these numbers to see what I will come up with. And we can, for example, change these to be different. Now, I'm kind of playing with this right now, so I haven't tested these specific numbers, but if we wanted to plot this, it looks like I have, maybe make these much bigger. Now you see that this is all changing here. So let's go ahead and look back to some of the values that I had. Whoops. Yeah. Sorry about that. I didn't mean to necessarily. There we go. Okay. So you can see that I have values that I've picked here for these. And actually, this is going to just keep going back and forth for me. So let's go ahead and look. So right now I have actually, I think I know what maybe the issue I have more than anything. Instead of using the global T, we'll go ahead and use the column that I have set up here as well. So we can add one more expression column for T. There we go. Now we can see the spirals. So, and sorry if that kind of happened quickly. So basically I added, instead of using the animation variable, which is a built-in variable called T, I have added a column that is called T. And what the program will do is, if you have a column that is being used, if there's a variable name, such as in these expressions where I have a variable for T, the program will initially look in columns for that variable name. If I take away this value for T, then it's going to use the global, then it looks for the global or would use the animation variable, but it's going to override with any variables that are in columns with those names. I hope that makes sense. In any case, so now when I go ahead and change my value for N, you can see how I'm creating this spirograph. So I have a column to define T, where T is currently, I just have the row number and I'm multiplying that by 0.1. So I have 0.1, 0.2, 0.3, and then T is for me currently is, it's going up to about 180. And I can just make this bigger and bigger and bigger. And then I can change the values of some of these other variables to see what happens. And actually, let me make the pen a little bit bigger. So already you can see you know, some pretty interesting shapes starting to form. If I make that 0, it will, things aren't going to calculate. But this is sort of what I did yesterday. I was kind of playing with these equations and coming up with some various shapes. You know, if you go online and you look at the equations that are used, then you can get a better sense for what each of these are. But it is, you know, it's kind of fun just to play with them and see what you can come up with. I think I had my n actually getting even much bigger than that. So you can make these even larger and, you know, kind of create, hopefully this looks interesting to you. I think this is pretty neat. This almost looks like it's a spring that almost even looks like it has a 3-dimensional look to it. So I can change that. And then, so one of the things that I wanted to show you is that once I create this one, say I wanted to create another spirograph and I wanted to keep kind of playing with these settings, I can take my current group that I have here of columns and place this in its own group. So this is, you know, we'll just call this my first one. This is just one. And then if I want to make another one of these, I can take that group. I'll option drag this to make a copy. This will be another spirograph. But currently, again, the first one is using these equations and it's tied to these global variables. So if I wanted to say have one of these specify what the value is for A, then I can add another expression column. We'll call this column A, the name of the variable. And notice that even when I first do that, now in this second group, the X and Y are no longer even being calculated because it's looking within the group first and it sees that there's a column called A, but I haven't defined what A is. So I'll go ahead and just keep A as my 0.967 that you see here. And then I have to define, I do have to tell it how many rows because I've just given it a constant, and I'll set it to n, which is defining the same number of rows for all of my, for everything that I've done so far. So now this second one is set to, again, have A set to that constant value. So if I change, actually, let me go ahead and do one more thing. We'll go ahead and clone this graph. And instead of having X and Y come from the first group, you can see if you hover over any of these menu items, it'll show you where it's coming from. I can go over here, and now in this group, I also have an X and Y. So if I take this group and drag it and drop it over onto my second graph, and let's confirm that, yep, now it's coming from this different group. So now if I go ahead and change my value for A, that's in the global space, I don't know how easily you can really see without, so I'm changing A in the global space, which is, again, changing my, my first graph, but the second one I have set up to use that constant value of A. So here I'm changing A, and it's changing, again, this first one, but the second one is now set to the same value. So I hope that sort of makes sense. It's basically, this is how I was thinking about, you know, how if you're using this to kind of design something and you come up with values that you like, again, you could do the same thing for B. I can set B to a specific value. So if I want B to be 0.1, I can make a column for B, set what that is. And now in my graph here, maybe I'll just go ahead and give this a color. So the one with the red line is now set. So A and B are set to constant values, but I can still use my global variables to explore other shapes with the first graph that I created. And okay, so the question about how would you see how these would evolve over time if, say, for example, we wanted to use our an animation variable to create an animated version of this, then why don't I go ahead and well, we could do this, I guess, a couple of different ways, but the main thing here is that right now I have n set to a slider that I'm changing. So it's starting with t equal to 0 and then increasing, but you could have the animation, you could use the animation variable for defining how many values you have. So because I can change these variable names pretty easily, and it's not going to, my equations are still set to, they're still hard coded as to what variable name they're using. So I could just change this n, for example, to be some other name. Now I don't have any calculations because n doesn't exist, but I can change my animation variable to be called n, for example. So now if I set this range to 0 to 1,000, then you can see the evolution of that in an actual, you can make a movie off of this, for example, and I can, have this be much bigger and have it keep going. And when you're doing this, actually, I can just kind of have this keep looping. You can even continue to edit while this animation is running. So there's all sorts of other things that you can do. Now, I guess one thing I haven't done here is I have not changed some of these other aspects of the canvas that we talked about. For example, I can set my size to be a specific size. I can go in again and set these margins all to be 0. And say I wanted to create something that I'm going to post on Twitter, for example. This is something that we do here. Then I would change my size to be that pixel size. So and I think I'm remembering this correctly. So the pixel size that Twitter would want would be 1200 by 675. Now, in viewing this on our screen on my laptop, that looks pretty big. So I can change the zoom to 50%. But then when I export this, it'll be the right aspect ratio for a post on Twitter. And now that I've set up this graph to be that size, I can go into the one that you see here, and I don't have to redo that. I can just click on the canvas here and go to the gear menu and say set same set same canvas setting for every graph. And now they both have that same exact setting. Okay, so I'm trying to think if there's anything else to show you here. Let's go back and look at the one that I created here, because there's some other styling that I did with this. Again, just honestly based on a bit of trial and error. What I ended up doing, I thought the black background looked pretty cool. And what I did was I actually am overlaying 2 different commands here. So let me hide one of them. So I have a command that is just drawing, using a plot command to draw my X and Y values. And that, looked kind of interesting. And then I said, well, what if I wanted to add some more color into this? Now, a points command has the ability to add color schemes. So all I did here was I said, okay, well, I'm going to take my X and Y column. I'm going to also plot this using points. Now this is, that's actually kind of an interesting look there in and of itself. The marker size here is different than what I had in the one that I created, but we'll go ahead and just make these individual solid points. And if you wanted to see the size on this, I'll just make this, oh, actually you can't see it at all because it's it's also black. So if I change this to, maybe change this to red, that's sort of bright on my screen, then you can see there are little points all along the shape. And what I thought to do was just say, well, what if I made this a color scheme? So I went into the points command and changed the color to using a color scheme. And actually, let's see what I based the color scheme on here. I based it based on T. So I'll just do the same thing again. I can base the color scheme on T. Once I select that that's the variable I want to base the color scheme on, I can just say create new color scheme, and it just will go ahead and create a color scheme for you based on the range of data that is being displayed. So that's basically what I did to kind of play with this and create a, sort of a unique look to this particular graph. So anyway, so I don't know. I thought that was kind of an interesting look, and there's just so many different things that you could create with this particular graph. The example that I have here has actually the variables A and B are themselves calculated based on the H and the N values, and that's what these equations or something that I found online that create this rows sort of a pattern. So if you're interested in doing that, you basically, instead of having let's see, where's my other spirograph that we were, nope, that's not the one. Did I bring it over? No, maybe I closed the file. Okay, well, that's fine. If you want to see what these equations are here, I'll just put on the chat the equation for, this is the equation I'm using for A. So again, having A be a function of N and H. And then here's the equation for B. So, what I'm doing here is I'm actually using a variable type that's an expression variable. And when you create that, then you have a place that you can put another expression where those variables then depend on these other variables that I've created. Okay, so I would love to see, if anyone comes up with any interesting spirographs, then please share them with us. We'd love to see that. Post them somewhere would be great. Let others know how you can make these things with DataGraph. Okay, so let's go on to the last example that I have, which is the Swan example. So go ahead and minimize this, go over to the one that you see here. Again, this has a lot of different elements, but you can break each one of them down and see what they are. Now, first of all, whenever I come across a file, because I've actually worked on this over time, I didn't just do this in one sitting. I, kind of played with this on different occasions. And when you're coming back to a file that you haven't looked at for a while, one of the, ways that we can kind of remember, well, what did each one of these things do? I can go to each one of my commands and use the hide button in order to remind myself what this particular command is drawing within my graph. So for any of these, for example, I can see, all right, that's what that's drawing here. This is drawing these different elements. And I even have my, my image of the moon, which If you've never brought an image in before, maybe I'll just show you that first of all as a simple thing that you can do. I think I have an image here. I've moved it. I cleaned my files up, of course, and now I don't see the image that I was originally playing with. Well, in fact, oh, here it is. This is the one I wanted to bring in. So any kind of an image that you have, you can take those images and just bring them right into DataGraph. So all I did was, and in fact, maybe that was so quick, I'll do it one more time. So I have this image here, which is this is just a simple, a PNG file that has an alpha channel. So it has a transparent background. And if I take this PNG file and I drag it and drop it right within my command list, it automatically will create for you a graphic command, which is let's see, one of the commands that is in the toolbar, I believe. I don't know why I'm not seeing it right now, but here it is right here, the add graphic. So this is, if you create a graphic command from scratch, it will ask you, where is the source of this? You can specify the source of the image that you want to show, which can actually even be another graph within your DataGraph file. But here, if you, again, drag and drop an image in, it will just automatically bring the image in, and that will be part of your file. So that's exactly what I did here for the, oops, sorry, lost my file here. Here we go. That's exactly what I did here for the moon file. And what you'll see is that when you bring in any image, everything that you have within the command list is drawn as a layer. So this one, for example, if I moved the image up to the top, then other things, actually, I set this up properly, so it's not necessarily doing that. Let me show you what I did. I was going to show you how you don't see it if other things are drawing on top of it. But because for this particular example, what I did was I set a background color for the whole image. So you can go into the canvas and set the background to a specific color. And here, for example, I have this set to a blue. I'm going to use the color picker. So I just pick the same color that's here. Now you're seeing, again, the XY coordinate system. It's looking sort of strange here because the font that I happened to have this set to from the prior graph was so big that it'll set those margins as though you might be putting some data there. Again, if I just put a point command, then that draws a single point and you can see the XY coordinate system. But to use the approach that I was showing you before, here I would just set all the margins equal to 0, and I would set the size to some specified size. And if I uncheck the draw X and Y numbers, then you're not seeing that outline along the edges. Let's see. So anyway, so what I did for this image is I set the background color to this blue so that when I take my image of the moon and put this on my graph, then, and again, I can sort of drag this around, then you can, nothing is going to cover it up basically, unless some of these other drawing commands do. So anyway, so the first part of this would be, again, this is actually set to this size, this 1200 by 675. So I can set that to my size in pixels. That is going to look, relatively big on my screen. So I'll move that around. Now notice I have the moon here. I can, drag this around, but I have it anchored into the upper left-hand corner. So if I want to set exactly the offset in the X and Y direction, I could set that in exactly what I wanted that to be. Oops. maybe not quite like I did there. I have to actually type the numbers in correctly. Anyway, so there we have our moon. What are the other aspects of the image that you see here? Well, here I am using a function command in order to draw these different sine waves. And I have this set up so it is also depending on some of these other variables. So there's a variable here called phase, and phase is using my global animation variable, my global animation variable t. So this is t times 2 pi. So if you, again, just create a variable and have t times 2 pi, so all of these things that are periodic with pi will cycle back uniformly. And so to show you what I mean, basically, when you're playing this specific animation, because I have the sine function set up to using 2 pi as a phase, then if you make a movie off of this and it's playing on a loop, you won't see any beginning and any end. It will just, when it ends, is exactly where it begins. So that's sort of a good way to set these up. And so basically here, this is just a function command. So I have a function command here that I can add. I'm using the sine function within these particular commands. I can, again, I'll paste this on the chat for anyone who is sort of interested in exactly what I'm putting in here. So I've got my my first sine function set up, as you can see here. Now, what's the problem with this? Well, let me make this, we'll go ahead and make this a white line like you see here. So right now, if you want to see what my X and Y values are for this, I am, and I can make this a little bit smaller so I can see for sure where this is going from. So you can see that my X range here is much wider than the range that you see here. So this is just the default range here is going from 0 to about 1. Well, I want to have a much wider range, and that's something that I can set pretty easily within my function command. And again, the whole extent of my graph is still adjusting. So if I want to I can go ahead and actually set these just to be a little bit more convenient for us so that I'm not having to change this all the time. So my X range being from -8 to 8, and my Y range here, I think was maybe something like, I don't know, -5 to 15. And now I have this nice wave going along the bottom. And because I'm using this variable phase within my graph, if I hit the play button on the animation variable, now it's going to show me that wave that you see here. And what I did in this particular graphic is I have a number of different waves, and one of them is actually 2 sine waves added together. So I have the sine wave here, I have my second sine wave, and then when I add the 2 of them together, then that's when I get the kind of cool looking sine wave that you see here. And again, because these are layered here, you do see that I need to have the bottom one drawn on top of this one to create that look. Let's see. So there's a comment on multiplex imaging. I'm actually not. I've never heard of that before, so that might be something you have to educate me on a little bit. But anyway, so the let's see. So I'm adding together these sine waves. And what are the other elements of this graph? Well, one of the other ones is the having the stars, which is simply done using a points command, and having the different values within the points command are coming from columns that are, again, changing with these phases. So if you wanted to look at what I'm doing with the stars, this is simply a points command where I have the X and Y location set within my within my data table, and I'm using random numbers to generate these. So I'm using a rand function. I've set up my X values to span the range of my X data. My Y values are also spanning this range. And then all these other things are also being set. So the color of my the actual whether it's opaque or not is actually coming from this color ramp. So I have a color scheme set to these points. The radius is also changing, where it's scaled by another column that I have set up using a random number. So all these things are coming into play to create this change where you can see how the radius of the column I'm using for the radius is the one that's changing with the phase of the stars. And then the last thing here that is key was adding in this little swan, which is just a Unicode character. So all I did to add this in terms of adding in that last element was to go into the under the edit menu. If you go under emojis and symbols, then you can find all these different symbols. And let's see, another one that I thought of using was a boat symbol, for example. And you could, take this symbol and actually place something that has this character into your into your graphics. So here, for example, I think how I did this was just maybe copied. I actually don't remember exactly that. Let me just go ahead and take this and, I think from here. Yeah, here we go. Okay. So I made the man in the boat my x-axis, but now that you have this symbol, I can take this and use a points command again. The points command is handy because I can, I can go ahead and specify exactly where I want something to be located. Let's see, that was not what I intended. Let me just make a symbol points command. I had a column selected, so it populated that. So here's a single point. And if I want to use one of these Unicode characters there, then you can make the Unicode character be the label that you use for this point. And then I'll increase my font. So now you can see, I don't know actually how well you can really see this, but there's a little icon now of someone on a boat. And then I can hide the actual point and you'll see the guy in the boat is in my animation. Now, right now, he's just floating in space. I want it to actually move with the wave. So what the points command has is it has the ability to just specify the X and Y location, which right now are specified with single values. So I could type in another number and move them around. But what I did here with the swan was to use the same equations for that top line to set the location for my swan. So I have an equation for my X and an equation, for my Y. And let me just pop this one in here. There you go. And then you can see now my boat is moving around on the waves. And I think what I did with the Swan is I also added another bit of an offset to kind of make sure that it was in the place where I wanted it to be. He still is, it's maybe a little bit smaller, but again, you could increase the font and change that a bit, but now you can see the emoji going on the waves. So anyway, so those were my examples that I had come up with, and I thought were sort of fun examples to share. There's so many different things that you could do. I guess just a quick what I didn't show you, which I think is useful for you to see, is how do I take something like this and then export this as a movie? Because ultimately that's what I want to do. I want to be able to share this. So I'm not going to draw my X and Y numbers, although I don't know that actually, I guess that wouldn't really be exported within the movie because it's outside of the canvas, but you might see the lines of the axis. So anyway, you can turn off those being drawn. And then if you go over to where the animation variable is, there's a little movie export icon that I'm just hovering over this now, so you can see the pop-up. And I'll just go ahead and stop the actual movie, even though I think I could still continue to play it. But if you click on this, then what happens is the program will create the movie frames, and you have this window pop up that you can also preview what the movie is going to look like. And you have the option of whether or not you output it in a Retina, Retina pixel sizes. If you don't want the movie to be too big, or you want the exact pixel size that you set within the program, then you can uncheck Retina. So here, for example, now it'll be back to the 675 by 1200 in terms of the size of my movie. And then you just say create MP4. I can give this my Swan name, and then it actually creates the movie. So if you have a file that's really big and has a lot of movie frames to create, you can do that in the background instead of, and continue to work within the program. Now, this actually only took a fraction of a second to make the movie. So this is the movie that I just created. And there it is.